Have you ever heard an ambulance drive by? Think about the frequency of the siren warning. As the ambulance is approaching, it'll be the woo, right? That frequency is going up when the ambulance gets close to you. As it goes by, it'll be this high pitch and it starts to drag. It'll be the woo, right? This is an example of the Doppler effect. Do you think the ambulance drivers are changing the frequency of the speaker as they approach you? No, that'd be a waste of their time. So it's a physical phenomena. Specifically, it means that if there's someone producing, say, sound or light, right, anything that's making waves, if the object is moving, if it's coming towards you, that's going to shift the frequency up. Now, if it's going away from you, then that's going to shift the frequency down. So the motion of the object that's producing the waves will shift the frequencies of the waves that you detect. Always think back to that ambulance example. As the ambulance drives by and goes away, that frequency goes up, then down. So instead of ambulances, let's shift to, say, galaxies. We can talk about examples of galaxies that are stationary relative to us, some that are approaching us, and others that are receding away. So the stationary ones, they'll be radiating all sorts of photons, and because between us and the galaxy, they're stationary, the spectrum will have no shifts. It'll look normal. Now, if that galaxy is approaching us, well, that's going to take the waves, and it's going to compress them. This is going to be called a blue shift. Right? Think about it as the energy of the waves are getting shifted slightly higher because they are getting compressed as it goes towards us. The wavelengths will shrink. So a blue shift takes where we expect to measure a frequency and shifts it in a blue direction. Now that galaxy was receding. If the galaxy was moving away from us, well, that's going to stretch out. Imagine the wavelength of these waves as they get longer. That's going to be our red shift. So once again, here's where we expect to see the wave, and as the galaxy goes away, it red shifts the spectrum. So this will affect the spectrums of what we're detecting, either a blue shift or a red shift. Unless it's stationary relative to us, then there's no shift at all. Using the Doppler effect, we can calculate how fast an object's moving and if it's approaching us or receding, moving away. Here's how it goes. Calculate to get the speed of an object, you'd say, what is the wavelength that we observe here on Earth? What's the wavelength that we measure? And then we subtract out the rest wavelength. Think of it as having a speaker making a high-pitched noise, and then if you chuck it away, right? As you chuck it away, the frequency will get longer. That'll be your observed wavelength. Now, if you pick up that speaker and put it right back next to you, that'll be stationary. It'll be at rest. So that'll be the rest wavelength. Same principle for light. So going through this again, the speed the object's moving is the wavelength of light that we observe minus the rest wavelength. Imagine it wasn't moving at all relative to you. Divide by the rest wavelength, and then you multiply by the speed of light, because these are electromagnetic waves. So let's take, for example, let's say we have an object. We measured that its observed wavelength was 659 nanometers. Now, there are other arguments, other tests you can do to figure out, well, what should the rest wavelength would be? And for this example, we said 656.3 nanometers. Now, divide by the rest wavelength, multiply by c, and you'll find that this object is moving at 1.2 10 to the 6 meters per second. So here's a key insight question. Is this object approaching us or receding away? The answer? It's in the difference here. Is this wavelength bigger or smaller than the rest wavelength? It's bigger. Bigger wavelength, that goes to a red shift, a stretching out. So this observed wavelength is red shifted, which means that this object is moving at 1.2 10 to the 6 meters per second away from us. So that's how you use a Doppler shift to calculate how fast things are moving in the universe.